Welcome back, Algebra class. Today we're going to be going over Chapter 13, Lesson 9 of Jacob's Elementary Algebra. And in this lesson, Lesson 9, we're going to be just briefly talking about equations that have a degree higher than 2. So did you know, it's interesting that the Babylonians actually were able to solve quadratic equations, but it wasn't until the 15th century, or 16th century, so the 1500s, that mathematicians found methods for finding higher degree, solving higher degree equations like x cubed. So whatever our equation is, we're going to consider its degree the highest polynomial value. So quick review. That's a polynomial. And that n up here is going to be a positive integer, including like 0. So basically, you could really say a whole number. N can be a whole number. And so if I have, for example, the equation x plus 3 equals 0, this is a first degree equation because the highest value of the highest degree, I should say, of any polynomial is 1, the power of 1. All right, now we've been doing quadratics. And so I'm putting all these in standard form so it's easy to tell what the highest degree of each polynomial is. So that would be x to the power of 2, x to the power of 1, and x to the power of 0. So what's the highest power? It's going to be x to the power of 2. So this is a second degree or quadratic equation. You probably know what the next one's going to look like. So what's the highest power? X cubed. So we could call this linear, quadratic, cubic equations. The fourth one there's no reason I'm using 3's. I could be using just anything as a coefficient. It could just be x to the fourth plus x cubed plus x squared. That would be fine too. This is going to be a quartic equation. So the highest value is to the fourth degree. Highest degree polynomial, that is the fourth degree. All right. So what was discovered is that it turns out we've already proved extensively how many solutions do you have for a linear equation? You're only going to have one. And you will always have one. Now for a quadratic equation, what's the maximum number of solutions you can have? 2. It's a parabola, so at maximum, it can cross the x-axis twice. All right? And then if we have a cubic equation, that has a total of 3 possible answers. Like it has up to 3 answers. You know, you could have one that has less or more than, you know, like, I don't know, you could have like 0, 1, 2 possible answers. But the maximum number it can have is 3. Any guesses what the maximum number of solutions are for a quartic equation? You were right, it would be 4. A quartic equation can have up to 4 answers. And so for each of these, it's going to be like, this is going to be the number of times it crosses the x-axis. So linear equation can cross up to 1 times. And any time that you have a linear equation, by the way, that doesn't cross it, let's see, that would just be like, you know, where there's no x value at all. So it's not even really a linear equation. So, but a line, that's just like y equals, I don't know, whatever that is, like 10 or something. So yeah, anytime you have an x value in your equation, it's going to have one possible solution if it's just like x to the power of 1 linear equation. Now, what are we really saying? We're saying that for any polynomial to the power of n, it's going to have n number of, I'll say n maximum number of solutions. It's kind of nice using this green marker because now it's roughly the same colors as the green in the math book, because math is only black and green. So, which I've always liked actually about this book. All right, so we're not going to be spending a lot of time going over crazy difficult equations, so don't freak out. You're not going to be having to learn new ways to solve cubic or quartic equations. It turns out that after a certain size, you kind of lose convenient methods for solving equations. Like, quadratic equations, there's so many ways to solve them, including the quadratic formula, which is probably the easiest once you memorize it. But in the case of large ones, and I forget at what point it begins to be this way, but when you get to really large ones, then you start to lose the potential of methods. But we're going to use some logic to solve a couple of example problems, which are going to be larger than quadratic in degree, or higher in degree than quadratic, I should say. So we'll begin with example number 1. I thought this was pretty cool. First of all, they have a picture of it, and I'm just going to hold this up. This is a cubic equation. How many times does it cross the x-axis? You can see it crosses the x-axis 3 times, so it's got 3 x-intercepts. How many answers does it have? Each of those times it crosses the x-axis is going to be an answer. So x equals, what is that, -4? I can't really tell from here very well. 1, 2, no, -3, I guess. X equals +1, and x equals +4, is that what it is? No, it's a little beyond 4, like 4 point something, I guess. So yeah, those are all going to be answers. If I said the wrong numbers, you use your own counting, and it was hard for me to see at that angle. All right. But they give you this equation that was a graph of the equation x cubed minus 3x squared minus 12 equals 0. So cubic equation, plus minus 12x. Here we go. Plus 18 equals 0. All right. Dang, and that one doesn't have like the y-intercept thing stops working. We'll get to that. Notice the y-intercept on that graph. That's not 18, that's like 2. So that's kind of a fun fact. We can use a normal y-intercept the way we always have for, like, linear and quadratic, but then when we get to cubic, I guess it changes. Anyway, they say how many solutions to the equation can you have? You could tell by graphing that it was going to have 3 possible solutions, but also just by looking at the degree. If the highest degree is 3, then that means you have 3 possible solutions. Even if you didn't see the graph. All right, now we're going to actually really solve the next equation. That one was just observing, all right, what's the degree, how many possible solutions are there, and how does that look on a graph? This one we're going to really do some math. It's a good opportunity to review what my old math book called the zero factor theorem. And I can't remember what this one calls it, so I'm going to call it the zero factor theorem. You'll recognize it though. It basically says that if, I think at least in my old book it says PQ, but you can use any 2 variables that you want, equals 0, then either P equals 0 or Q equals 0. Because anything times 0 is 0, so if these 2 factors multiplied by each other are 0, then one or the other is going to be 0. Technically, both could be, I guess, but, you know. So setting things in standard form allows us to use that zero factor theorem. Example number 2, we're going to actually solve this one. X to the 4th plus 2x cubed minus 3x squared. Don't be intimidated when you see a new type of problem and they don't give you any explanation, because it means that there are tools that you already have that if you use them in a different way, you can find the answer. So you already have what you need to do this. That's a good lesson for math in general. So how on earth are we going to find up to 4 answers for this equation? Because it's to the power of 4, so there could be up to 4 answers. How can we simplify this at all? Well, let's use what we're familiar with, which is factoring. Do you see anything we can factor out of all of these? I see a common factor in all 3. X squared. So I can take out of that x cubed and x squared, and out of this x to the 4th and x squared. So if I factor out x squared, then what I get, I'll use the distributive property, x squared, this with divided by x squared is x squared, so x to the 4th divided by x squared is x squared, plus 2, x cubed divided by x squared is x, minus 3, x squared divided by x squared is 0, or sorry, 1, so 1 times 3 is still 3. So this is what we get. So now, using the zero factor theorem, I know that either x squared is 0, or x squared plus 2x minus 3 is 0, because all this counts as one factor since it's in parentheses. Now, can I go even farther? Because I need a total of like up to 4 possible answers. So is there anything more I can do? Yes, there is, because this trinomial can be factored into a couple of binomials being multiplied by each other. So x squared, parentheses, we'll do our whole FOIL thing. I like doing the box. So what we need in the box is we need 2 factors that equal x squared. We need 2 factors that equal -3. And then we need the factors that equal -3 to be added together and equal +2. Now looking at this, if we have x squared, the only factors for that are x plus x, or x times x. So I can put those down with confidence. Now, what about -3? What are the factors of -3 that added together are going to equal +2? First of all, if we have a negative number, what are its factors going to be? One has to be positive, one has to be negative. And if when we add them together it gets a positive middle value there, then that means that the larger of the 2 factors has to be the positive number. So what are the only factors of -3? Just 1 and -3, or -1 and +3. So which one will it be? If added together it equals 2, it's going to be +3, -1. And so now we can go ahead and do this. -1 times 3 is -3. -1 times x is -x, or -1x, however you want to do that. And then 3 times x is 3x. Do we have any like terms? Yes, we do. 3x minus 1x is, in fact, 2x. So I can take this trinomial, factor it into x minus 1, order doesn't matter, according to the commutative property of multiplication. All right, so I am set up to see more than 2 answers for this. Don't need this anymore. All right, so at this point, what I know is that either is EI, not EE. X squared equals 0, because one of these 3 factors has to equal 0, remember? For the whole thing to equal 0. Or x minus 1, in parentheses, equals 0. Or x plus 3, in parentheses, equals 0. Those are my 3 options. How do I get option number 1? Well, I could do this over here. If x minus 1 equals 0, then I'm just going to solve for x by adding 1 to both sides. So one of the possible answers is that x equals 1. Now let's take a look at this option. Isolate x by subtracting 3 from both sides. So the second possible answer is x equals negative 3. And then what's our third possible answer? Well, if you square anything to equal 0, it's going to be 0. So if x squared equals 0, then that means our third possible answer is just that x equals 0. So this quartic equation, as a quartic equation, meaning its power is 4, it could, quartic equations in general have potentially up to 4 answers. How many does this particular one have? This particular one has 3. And they are 1, negative 3, or 0. Those are the 3 possible answers. We have one last example I want to do. And this is the last example in this lesson before you get to the homework. This one is really interesting, and I thought it was very clever how you solve it. So first of all, what degree equation is this? The highest degree polynomial in it is going to be 3x cubed, and you already know because it's in standard form in the highest degrees to the left. So this is a cubic equation. So what's the maximum number of answers it could have? 3. Now, how are we going to solve this? First of all, take a look at it. Do you see anything you can factor out? I do. Every single one of them has x to a certain power because this one doesn't have a constant in it. So I can actually factor out the x. Divide this by x and you get 3x squared. Divide this by x and you get negative 24x. Divide this by x and you have 15. The next thing I would do, generally speaking, did I copy this one wrong? Oh no, yeah, I didn't copy it wrong, but what I did do wrong is I didn't notice there's actually more you can factor out. Not just the x, but the 3, because they're all multiples of 3. So I can factor out 3x. So then x cubed divided by 3x is actually going to be x squared. Sorry for missing that. Negative 24x squared divided by 3x is actually going to be negative 8x. And then 15x divided by 3x is going to be 5. All right. So already I can see, if I think about my zero factor theorem, if p times q equals 0, then either p or q equals 0. So here's a factor and here's a factor. So one of my possible answers to this equation is going to be x equals 0. I know that because 3 times 0 times anything else is going to equal 0. So 0 is one possible answer. Maybe I'll just write that off somewhere. That's going to be one possible answer. Now, we could try to do what we did in the last problem and break this down, but we have an issue. Because if I tried to factor this trinomial into a couple of binomials, then I get my x squared just fine, but then I need factors that equal positive 5. And since there's a negative in the middle and then a positive here, then my best bet is to do 2 negative factors that when added together are going to be negatives because they're both negative, and multiplied together are positive. So like negative 1 times negative 5 multiplied together, that's going to be positive 5. So that gives me positive 5, but I have a problem here. What's negative 5 times x? It'll be negative 5x. What's negative 1 times x? That's going to be negative x. When I add these like terms, does it give me what's inside the parentheses? No, it gives me x squared minus 6x, not minus 8x, plus 5. So that's a problem. I can't actually factor this down any farther. And in the absence of being able to factor down, what could I do? Well, maybe, and I'm not even 100% sure it would be worth it, I could try the completing the square method. Not going to go there right now, because it turns out there's an easier way to do it. The zero factor theorem or whatever they call it in this book, I can't remember, says either 3x equals 0, or really in this case just either x equals 0, or 3x equals something else, and all of this together equals 0. So therefore, could I not take this equation by itself and just know that x squared minus 8x plus 5 equals 0, and then solve this by itself? I could. And again, I can't do it by doing binomials, so what I'm going to do instead is I'm going to use the quadratic formula. I think I'll continue that. Yeah, okay. I can do it over there. I just have to write small. All right, quadratic formula. Let's see if I have it memorized. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Did I do that right? Yep. Hooray for me. So now we got to plug in the values of a, b, and c. If you're at all lost, you can go to the last lesson because we did this extensively in that. Where's a good red marker? I'm not seeing my red marker. Oh well. Maybe I'll try using a blue one. All right, so the coefficient of x squared is our a, and so a equals 1 because there is no coefficient listed. What about b? b is negative 8, and then c is our constant positive 5. Now we plug those values in, always putting them in parentheses, otherwise you'll get everything wrong. Negative b is going to be negative 8. Square root of negative 8 squared minus 4 times a is 1. And c is 5. All right, all of this over 2a. Carry all this down, and we're going to simplify that because there's no need to have such a crazy looking 8. Plus 8 square roots of 8, negative 8 squared is 64, minus 4 times 1 times 5 over 2 times 1. Carry this down, x equals 8 plus or minus the square root of 64 minus 4 times 5 is going to be minus 20 over 2 times 1. Okay. Then, may run out of room, x equals 8. These quadratic formula problems take so much space. Plus or minus the square root of 44 over 2. Now, I've got a bit of an issue, which is, what on earth is the square root of 44? Well, let's go back to another lesson. I'm going to move all of this over here, since we ran out of space. And I know that I can actually factor the things that are inside to find perfect squares. So 44, if we factor it and try to find any perfect square factors in it, yes, 4 is a perfect square. Divided by 4, and then we have 11 left over. So here's how I'm going to rewrite this. X equals 8 plus or minus the square root of, and then 44 is going to be 2 squared, which is 4, times what's left over, which is 11. When I find the square root of something that's being squared, I can get rid of that, move it out. All of this over, I'd stopped doing 2 times 1, I guess, by mistake. But it doesn't really matter because we know it's 2. So anyway, I'll just be real consistent though. So that means x equals 8 plus or minus 2 times the square root of 11, all that over 2. What can you do when you're adding / subtracting things in the numerator over a common denominator? You can actually subtract, split the fraction in half and say x equals 8 over 2 plus or minus 2 square roots of 11 over 2. Can we do any canceling? Yes. 8 divided by 2 is 4. X equals 4 plus or minus, and then cancel out these 2's, the square root of 11. Now, you might be thinking, wait a second, what kind of an answer is this? It is a good answer because it means either x equals 4 plus the square root of 11, and we don't have to solve for what the square root of 11 is, or x equals 4 minus the square root of 11. So how many possible solutions do we have for this cubic equation? It turns out we have the maximum number of solutions. We realized from the very beginning, when we factored out the 3x from all the terms, that according to the zero factor theorem, p times q equals 0, if one of these three factors, 3 times x, 3x and this all in parentheses, if one of those three factors is going to equal 0, then x has to equal 0 is one possible answer. Or you can have the two possible answers out of this that would make this whole phrase equal 0. And the two ways that this whole thing are going to equal 0 is if x equals 4 plus the square root of 11, or if x equals 4 minus the square root of 11. So the final answer is x either equals 0, or it equals 4 plus the square root of 11, or it equals 4 minus the square root of 11. So that was a pretty difficult problem. It used a whole lot of dynamics that kind of accumulate from past lessons. You know, so it's kind of intimidating. And then it's also intimidating because it has the square root of 11 in the answer. But hopefully you were familiar enough, like, you know, you were used to enough the different procedures in it that it could all make sense. If there's anything in there that you didn't understand, like any particular part, hopefully by now you are okay, like, you know, dealing with the quadratic formula, because that'll really help you on the test. It's really useful for the more difficult quadratic equations. And definitely I hope that you got that zero factor theorem idea, that if p times q equals 0, then one or the other has to equal 0. So I'm going to go ahead and end this lesson right now. Hopefully this video was helpful. Feel free to let me know if there's any way I can improve these videos. Study hard, and I will see you next time.